Welcome to everyone joining the Reacton Heavy Vehicle webinar. I hope everything's well where everyone is. We've got some people joining us from all over the world. Just wait for a couple more guys to join us, and we're going to start on time. Yeah, let us know, guys, if you can't hear us at all.
Maybe if Emma just comments quickly, just to say how the sound is, just to double check.
Thanks, Nils. Great stuff. You'll have to forgive us. This is our first official webinar, so if anything bad happens, we're allowed to claim it's our first one. So be patient with us. So we got joining us. Cool. Yeah, got some more guys coming in. So we'll start talking. Just wait for a few more people to join us. As per all the webinars, if you've got any questions, what we're going to do is drop us the questions on the Q&A section below. When we get to the end of the presentation, we're going to be going through the questions, and while Ed's talking through the presentation, we might answer some questions if they're relevant as and when we come to some of the sections. We've got a few videos in the webinar as well, so hopefully guys, they're going to play okay for you guys. What we will do is at the end of the webinar is also send you a copy of the presentation if you want to watch the videos in better quality. And I'll make sure the marketing team make that available for everyone to download. So I think we will kick off to keep things nice and in time for everyone. So I'm just going to go ahead, guys, and share the presentation with you. Okay, guys, hopefully you can all see the presentations all up. Okay. Okay.
Okay, so we'll make a start. Just want to say thank you for everyone's attendance here today. And I know, given the time zones, it may be early or very late for you, but we just hope that you can come away from this presentation with a lot of very useful information, and to be able to help understand vehicle fire suppression, especially for the heavy vehicle segment. My name's Ed Chivers. I'm the Global Product and Certification Director, and I've got Ed Barnes, the CEO of Reacton, with me today. As Ed mentioned, we're going to have the questions at the end, so feel free to type them in as we go along, but we'll try and leave plenty of time to answer them. So, you know, a very simple introduction here is what is vehicle fire suppression. So you can see on the side here we've got one of our systems on a machine, but what is automatic vehicle fire suppression? So really it's a way of suppressing or extinguishing a fire event on a vehicle. And when you say suppressing, that's controlling. So they are two different items there. It will need to be completely autonomous. That means that the detection system has to be completely attached and combined with the suppression delivery system to be able to trigger the system and have no intervention from any humans at all. And what you commonly see for these automatic vehicle systems, they'll be designed in a total flood or a local application method. With the vehicle fire suppression world, they are typically pre-engineered. And yeah, really, if you wanted to sum it up, what an automatic vehicle fire suppression system is, in its simplest form, you have a detection system, an actuation system, and a delivery system. That's it in its simplest form. And when all the agents that are used on these vehicles have already been tested, and they are the ones that are correct for the fire, the classifications of fires that you see on vehicles, such as Class B with the hydraulic fuels and flammable liquids. So what we want to talk about on this slide is what does this actually look like? What is a typical fire suppression system? So we can break these up into key areas, which is probably the easiest way to go through this. And given the time of this webinar, we can't go into extreme detail about each part. But the first part of the system is the containers. So if we have the extinguishing agent storage system, and we've got a picture of one of those up on the sort of top right. In this application, we've got a dry powder and a wet chemical. But the extinguishing agent storage system basically holds your extinguishing agent, and these systems can either be stored pressure. So in the Reacton sample, we have it at 25 bar. However, there are some systems out there that are unpressurized and use a cartridge to propel the system. You then have your detection system, and again, this can be achieved in many different ways. The most common sort of type that you see in vehicles, because of the complex nature of an engine bay, would be a linear sort of detection, and sometimes that can be electronic, or it can be pneumatic with the burst tubes that Reacton make. We have a distribution network, which essentially is another way of talking about your pipe work, your discharge hose. This is where the agent comes out of the cylinder and is delivered towards your discharge nozzles. And then you have the actuation system. This is really a means of actuating your cylinder. Some people may have a cartridge. You may have a valve which is directly operated, as in the instance with the Reacton valve, or there's other methods available. We have lots of support information about this if there's people who want to know the examples out in the real world.
Yeah, and I think just a point on the actuation system is it's when you're considering a vehicle system, vehicle fire suppression system, is often people look at the different technologies but don't consider how reliable the actuation system is. So, for example, on some systems, you have a number of actions that the system needs to take before the system will fire. So, as Ed said, that could be striking, that could be a metron that drives a pin through the cartridge. There's other simpler systems like ours that require only one moving part, which is just our loss of pressure system. So the actuation system that Reacton choose is primarily the pressure loss system because it's the most reliable actuation system in the world. It cannot not actuate when pressure is lost above the valve. Whereas on electronic firing systems, you have a number of failure points. And with cartridge-operated systems, you also have a larger potential problem, which is where a hose connects the pressurized system to the storage tank. And we've seen over the years in Reacton and our sister company, Fireward, seeing those systems fail because the hose has deteriorated between the two parts. So keeping your actuation system very simple is one of the key parts to having a reliable vehicle fire suppression system.
And then on to the last part there, we have our ancillary functions equipment, and that could be seen as a manual actuator, an in-cab monitoring system, battery isolation, or engine shutdown. And these all have their purpose when you're speccing your system for an automatic fire suppression system for your vehicle.
Yeah, and the engine shutdown that Ed just talked about is what I would deem, in my expertise, is probably one of the single most important components that gets overlooked. If you are not successfully isolating the source of heat and fuel or flammable liquids in an engine bay very early on, it is unlikely that the system is going to extinguish the fire. So we work on the majority of our principles unless otherwise the application it doesn't support immediate shutdown. We shut down all of the equipment immediately when we detect the fire. The delaying of that, all that does is increase the damage to the machine and decreases your chances of extinguishing the fire.
Okay, and then on this this slide here, we've got why heavy vehicles need automatic fire suppression. And you know, a lot of these are very obvious. We're going to run through them pretty quickly, but yeah, they have an absolutely demanding life, and they are worked, you know, within an inch of their life because it earns you money. If the vehicle's not working, you're not earning money, so they are pushed extremely hard. So all of this excessive sort of functions that you have on that vehicle increase the temperatures. You know, you have to increase the cooling. You know, then there's, you know, the flammable fluids are getting much hotter, and it all creates this perfect environment for a fire. And yeah, this is why we see them. And you know, it's extremely important to have suppression on these. But if we go to the next one, we've got the problems of the human part of this, where they may not be around to be able to use a fire extinguisher to put this fire out. But even if they are they trained? Do they know where to apply it? Are they going to be able to get access to that fire? The last thing you want to be doing when there's a very high energy fire is starting to open up some of the engine compartments and, you know, be that close with the fire extinguisher. So this is where the automatic fire suppression side is really key.
And I think you're going to see that, everyone, later on in some videos shortly, is two things that Ed just mentioned that I want to reiterate, is the human factor, and you're going to see one of the videos of a large fire on a piece of equipment shortly. Is the machine is totally unmanned and is operating at full capacity when the fire happens. So I think the time to when the fire ignites to the time that the first person is on the scene is around about 25 seconds, 30 seconds. So the issue you've got there is if a fire has been established for 30 seconds, not only have you got a significantly damaged machine, but you've also got a more difficult fire to extinguish as well. So the speed at which these systems, you're going to see in some videos shortly, and that makes up, that's the big thing for me. The high temperatures and rapid airflow is another point, as well as debris in engine bays. I know quite a few of you on the webinar at the moment have experience of vehicle fire suppression systems, and no doubt you've seen particular pieces of equipment in biomass and in waste applications or recycling applications where the maintenance is poor and there's a lot of combustible material in those engine bays. And
then if we carry on, really it's you know, the scale of fire on a heavy plant equipment is normally very large and then significant, which also, you know, in turn has a lot of damage and then downtime, which again equals cost. So yeah, this is something we really do need to deal with, and you know, insurers really are taking note on this and looking for solutions. And really the next point is, this is why, you know, you need automatic vehicle fire suppression systems.
Yeah, a number of insurers that I have spoken to over the years, as well as recently, especially what they call sensitive sites, which is sites that have high fire risk. Their biggest concern, and the reason that they mandate fitment of vehicle fire suppression systems, is because if the vehicle catches a light or there's a fire event inside a building, there's a high probability that it's likely to either catch waste piles or or residual piles or stock alight, and then obviously that ends up taking the entire building with it. So what in essence we've protected could be £150,000 or $200,000 piece of equipment from fire, but actually what we've prevented is a £4 million or $5 million claim where it was an indirect loss associated with a vehicle catching fire. So that's predominantly what we see when speaking to our clients. And then, as Ed said, the automatic fire suppression removes the need for human intervention when fire occurs. You're also going to see that in a video shortly about when a human does intervene, how dangerous it can be. So this video is a fantastic video. Again, you'll get this on the presentation. This is a Reacton fire suppression system at work. The system here is fitted to a large industrial shredder. So it's a £300,000 piece of equipment. It shreds wood and other recyclable materials. It operates on its own. It doesn't have an operator located near it. What we can see here, hopefully you can see my mouse. As you can see, this is the loading area of the machine, and below the loading area is the engine compartment, and this is the radiator side, and you can see some debris on here as well, which is important when I play the video. So hopefully, I'm just going to check you guys can see the video correctly. So we can see he's loaded the particular shredder up with combustible material. In this case, it's wood. Just checking you guys can see. Okay, yeah, so the video is working. So we can see that the machine's operating on its own. You can see it's shredding wood, and you can see everything's fine in this particular operator's life, and there's no pre-warning that there's likely to be a fire at this stage. So the first signs of fire, we can see we've got some smoke coming out of the machine now, and this is a hydraulic hose that is starting to fail, and up to the top of the building is 10 meters, so you can get an idea for how high the flames are when you see the ignition. So what we see is the hydraulic oil igniting. And what we see is the system has detected the fire and extinguished the fire in the engine bay and the surrounding areas. And the small fire that you can see on the back here is actually a piece of wood on top of the radiator. I think the video's, some feedback is the video's a little bit behind where we are, so apologies for that. So that is the fire successfully suppressed. And what you can see, I said in a slide earlier, was there's now the human intervention. He's got great aim, this guy, with a fire extinguisher. And you can see him just extinguish these small auxiliary fires next to the machine. So I'm just going to pause the video there and just let 2 seconds for you guys to catch up, because I think it's slightly behind. So what lessons have we learned there? We've learned how quickly the piece of equipment has developed into a large fire. You saw within 3 seconds the Reacton automatic fire suppression system has successfully extinguished the fire. Because of our dual agent system utilising dry chemical, we're able to fill the entire machine with extinguishing agent, also extinguishing hidden fires that a lot of wet chemical systems are unable to do. The machine, in summary, was back up and running 4 hours later with no damage. So we had a very happy customer who, the system did exactly what it needed to do, and all he simply needed was an exchange of cylinders and a recommission of the system. So we're just going to walk through a little bit of fire data now.
Yeah, we just wanted to go over some pretty striking stats surrounding the vehicle fire suppression world and insurance claims and costs. And really, this is sort of reason why Reacton was born and why we passionately develop systems, because we see these stats that are out there, And really, the first one we've got here, 62% of vehicle fires start in the engine bay, and 36% of fatal fires start in the engine. Then we have quite a striking number there of vehicle fires each year, and then to have 225 million in property damage is a significant number as well. We move on to the next one here, where we've got 2.7 billion paid out by insurers. So they want to make sure that they're reducing the risk there, and they've got a system that works every time when it's required. So this is why Reacton develop our systems and spend so long in our research and development sort of phase, and want to make sure that these systems work when they're called upon. The next one here, we've got 300 fires attended at waste sites each year, and 16 million to the fire and rescue services in costs. And our last one on there, we've got the 20% of vehicle fires attended by fire and rescue services were heavy vehicles. So that really sort of leads on to our next slide here, where we want to talk about the types of extinguishing types of systems and their extinguishing agents. We know that there are many different types. They come in different sizes and forms because the vehicle, the heavy vehicle market has a huge range of vehicle sizes. But one thing that is very important is you can really condense this, and they all come under the same sort of category of either a dry powder or a liquid-based system. And the reason for that is because they have the best method of extinguishing fires that are found on vehicles. And they're proven time and time again throughout all the different vehicle fire standards that are out there.
Yeah, and what Reacton does in those images you can see there is we, unlike a number of fire suppression suppliers, because we have access to all the different range of technologies, dry powder, liquid-based systems, water-based systems, we are not limited to sell through our distributors to customers just our system and tell you it's the best. What we do is we work on it in a scientific manner to ensure that our systems deliver the best performance, regardless of necessarily what agent we use. So for most of the testing and most of the approval side, you will see we use dual agent or dry powder systems. The reason we don't offer a liquid-based system as what we would deem as being our primary system, we do offer a liquid-based system for specialist applications, but the reason we prefer dry chemical is because of its performance, the significant performance gain you have with dry powder over liquid-based systems. So we'll run through this pretty quickly because we're going to run out of time.
Yeah, so we know we're really motoring on with time, so we've got the advantages here of dry powder. Some real key points from that is nice takeaways are it's 5 times more effective than water by weight. That's a very useful bit of knowledge there. And it's the coverage, it's the safety margin that I just mentioned that you get with dry powder. And then we have disadvantages there where inherently it doesn't have much cooling properties. And again, you do have a clean down, as you do with any vehicle after a fire event anyway. And we can move on to here.
Just going to pull them all in so you've got them.
Yeah. Move on to the wet chemical here. We've got an image on the side there. That's actually from one of our videos you'll see, I think, in a minute, from our dual agent system, protecting the superheated surfaces. But wet chemical, again, it's amazing at cooling, and with that, it has great reignition protection. And because it's a liquid, it can follow the path of a flammable fuel and then have a nice blanketing film forming over the top of it to keep it separated from the oxygen. The disadvantages with the wet chemical systems, they have much more nozzles and a significant increase in agent quantity on a like-for-like system.
And then in the fire testing, we know that they're very limited in their coverage. We know that they struggle to extinguish large fires, which will be something you'll see in the comparison documentation we'll be sending you out after the webinar. Wet chemical systems are unable to deal with hidden fires, and they're fires that are located in obstructed areas, so parts of the engine bay that are not directly within a nozzle's range, and that's significant. On that previous video we just saw, if we didn't have dry powder in there, I would say it's completely unlikely we would have put out any hidden fires in that. I would say it's unlikely we would have extinguished the fire in its entirety. And we certainly would have had more damage to the machine in some areas, because we just wouldn't have been able to have covered every area in that engine bay, as you only have a limited number of nozzles. And as Ed said, it's also not suitable for electrical risks as well. So they've got advantages and disadvantages between the agents. As a business, we like wet chemical, we like the cooling ability it has, but we engineer it to deal with the cooling side rather than the main extinguishing side of our systems. So what we're going to just watch on now is we're going to watch a similar type of machine. I'm going to pull this full screen. This is a same industrial shredder from the one we just saw. And I'm going to show you what happens when you use a system that isn't designed to deal with large hidden fires as per the PMARC testing, and also isn't designed to deal with hidden fires. And as I said, hidden fires are those fires that are out of the reach of nozzles, below the engine, in small compartments next to the engine, or if flammable fluid is sprayed across the engine, it will get into areas that a wet chemical system can't get to. So we've got a shredder here, we've got material coming off the end of the machine, and we've got another loading shovel loading the machine, the shredded material, into the hopper here. So what we're going to see is the engine is located in this area, so hopefully you guys can see this, just where the bright lights are. And the fire is going to happen where my mouse is now. So it's going to start just on the back side, the lower back side of the engine. And this system in here is a water mist system, a well-known water mist system brand. And if I flick through to when this fire starts, so it's about here, and I won't be able to play you all of this because we will be here until about 1 o'clock in the morning, I think. So you can see a fire that's started, you can see a fire that's just started below the engine bay here. I'm going to take this slowly because I know the video is playing slightly slower than we'd want. So we had detection very early on in our system, and this particular system had only detection installed around the top of the engine bay. So you can see this fire growing, and the fire burns for around 2 minutes before the detection actually picks up the fire. Now, this is what we would class, as per the standards, as a hidden fire. It is hidden inside the engine bay, away from the nozzles of the fire suppression system. The other disadvantage you're going to see when we go to the extinguishment side of this is the water that's used in the system is evaporating before getting to the seat of the fire. So the disadvantage again of water is knowing the flow rates and how much water is going to be needed, or how much mist is going to be needed to fully extinguish that fire. With dry chemical, we don't have any of those problems or the need to really look into too much detail with those calculations. Once we fill the void with dry chemical, it will extinguish the fire. So we can now see flames starting to come from the top of the piece of equipment. The operator has realised there's a fire in the engine bay. I'm just going to shuffle the video on a little bit. Hopefully it's playing okay for you guys. So you now can see the fire now coming from the top of the engine bay. And what you'll see is you will see the water mist system activate now. So you can see the steam being generated from the system. But if you look at the bottom of the system, you can, bottom of the machine, you can still see the fire is ignited and not being suppressed. So a lot of foam and water mist manufacturers of systems talk about long cooling periods and lots of cooling from their wet chemical systems. Well, cooling is no good if you don't extinguish the fire. And this is a prime example of that situation. So being able to show you have A+ rated performance from a fire suppression system ensures that every fire scenario you experience in an engine bay can be extinguished. This system on here will only score a C in the fire extinguishing rating, which means that if a certain type of fire occurs, like the one we're seeing in front of us, the system is not designed to extinguish it. But customers that buy these systems are not being made aware of the potential disadvantages or weaknesses in systems, which is something that Reacton heavily works with its distributors and customers to work through. So what we can see that the system's now finished discharging. It has not extinguished the fire. And what this leads to in a very quick way is the entire machine being burnt to the ground and also causing about £1.5 million worth of damage to the building that it's in. And this is an operator who is working on his own at night. So this is quite a dangerous, this is a very dangerous situation that's occurred, all because of an incorrectly specified fire suppression system. So that's why you always look out for the A+ performance rating.
So from that, we are now going to talk about the dual agent system. So really what we've seen there, we've spoken about the advantages and disadvantages of both dry powder and wet chemical. And what Reacton are doing here with their dual agent system is combining both of those together and basically taking the advantages of each system. So you get the massive fire knockdown from the dry powder, but you also get the cooling and the reignition protection from the wet chemical side. So this is why this system is so popular and so effective. It has the highest level of vehicle fire protection you can have by combining the two systems. It's extremely economical compared to that of just a liquid-based system, about 40% less agent required. And this is also recognised by the NFPA and advised for them. I think it's NFPA 122 that actually advises that you should be using dual agent systems on certain vehicle classification. So one little point at the end there is Reacton's dual agent system, approved and A+ rated, is as small as a 4 kilo powder and a 4 kilo wet chemical.
Okay.
Oh, sorry, a bit premature there. So the next video is for our distributor network and for all of our engineers around the world. We do some interactive video training. And at the end of the installation training is what we do is we set off the system that we've installed. On this particular training video, this was a CAT loading shovel. So what we're going to see is we're going to see a P-Mark A+ rated dual agent system being set off from an in-cab manual actuation point. So inside the operator's cab, we're going to press the button. You'll see the system discharge, and we've got a nice camera in so you can see the wet chemical doing its trick. The machine's running, and this machine has engine shutdown fitted, and it has a battery isolation option as well that cuts the battery basically isolates the batteries when we detect or manually actuate the system. So I'll let David Brand, one of our engineers, take over the introduction.
Okay, so we completed the installation. We're now going to show you a system discharge. We're going to activate the system from using the in-cab button inside the cab. You'll see throughout the discharge that the engine will shut down and the batteries will isolate.
spraying onto the manifold at the end of the video. I'm just going to get confirmation that the videos are finished. So, I mean, that although a brief video, and you'll see it in the presentation pack when we send it out, we've got lots of these clips which we want to make available to everyone in the webinar and everyone that's interested in learning more about the vehicle fire suppression systems. It's really good for us, and we really enjoy it because very little is known about vehicle fire suppression systems, and there's even less videos and interactive content about them. So that's something, if you've got any questions at the end of this, you need to get hold of us, and we'll get any kind of content or any kind of videos out that you'd like to see in the video, and anything else we see or you might be interested in. So we're going to quickly pull on to PMARC now.
Yeah, so we know we're getting through the time here, so we won't go through this in too much detail, but really we want to talk about why Reacton have chosen the PMARC. But first of all, what is it? Basically, it's saying that you've made a decision that you want to have a quality system that has been confirmed by a third party. It means the product meets or exceeds these stringent requirements, and they're internationally recognised standards that they're being tested to. But it also looks at the manufacturer itself. So it's not just fire testing, it has a lot of other parts to it. So when we talk about the dual agent system, because it's heavy vehicles, it's the PMARC SPCR 199, which is their certification rules 199. And it's been developed purely for the heavy vehicle systems, the engine compartments of heavy vehicles. And this is really the key performance level certificate from RISE for vehicles, and it has hugely demanding tests, and they've been made much harder than the previous SPCR test, which is 183, where you're not allowed any reignition. So this is an extinguishing system, not really a suppression system. So we are not allowed any reignition, and we have the addition of tests where there is no closings on the actual test rig. So you can have an open ceiling, you can have an open floor, or the complete test rig open, which really does prove the local application route of these systems.
Yeah, so in essence what that looks like on a machine is, those that are familiar with heavy vehicles will know that a number of machines don't have a belly pan or a pan underneath the machine, they're open. So the more open you make an engine bay, the more difficult it is for a system to extinguish. So what you might find is systems being installed to large wood shredders that the engine sits above the machine and it's totally open, but the systems have always been tested in an enclosed environment. So you would argue that it's never been tested to deal with fires in a totally open manner. So that's why the classification and the ratingness of openness is something that we and insurers look at when considering if a fire system is suitable for the application. So, as I said, if you take a wet chemical system like a water mist or a foam system and you make the enclosure open, a water mist system is unlikely to extinguish any fires because it's not able to contain the steam that's generated that inerts the fire. So, openness, or the level of openness, is really relevant to how well a system performs. And Reacton not only deliver an A+ rating, so we pass all of the testing, and we're not going to have time to go through that today, but it is something that I'll be sure to pass on any questions on. But also we have a rating of openness of 3, which means that the system is suitable to be installed to an engine bay that is totally open and it's not enclosed. So I think if we just skip through this, I think, because we're going to run too tight. So I might just take this. So we selected PMARC for a really simple reason. It enables a really fair comparison between fire systems. So it enables you to compare, as I said earlier, the difference between a system that is certified to deal with extinguishing fires in certain environments and some that are not. Also, you've got very standardized test protocols that are used, so repeatable fire tests. Unlike some standards like SPF tests, an SPF accredited system, it's a one test pass, you can't repeat the testing, and it's not very scientific. There's a robust risk assessment that goes with each vehicle before you install, so we're looking at vehicle design as well as we're looking at a full risk assessment before a system is fitted, and that's in line with the PMARC standard. And the design and production and installation control that is done by RISE ensures that they check our systems are installed in accordance with PMARC, and that we're following our own standards that we set for it. I think we'll come on to how do we get it. I think this is relevant, isn't it?
Yeah. Really, what the PMARC is made up of is the fire tests, which there's a report there for our 8 kilojoule, which is made up of the 11 tests, the 11th one being the reignition. Then you have the temperature cycling or mechanical stress resistance tests, which we're going to detail in a bit. And then you have the corrosion part as well. And then that all adds up for you to get your certificate. But there's a step in there which is the auditing of, there's a factory production control, there's an audit of Reacton, our manufacturing, our quality, and how we track everything. And they audit our installs as well.
I think just moving on pretty quickly, but it looks on screen, guys, that it's a really simple process. It's not. It took us 24 months, 2 years to get our PMARC 199 system certified. It's not just 4 pages, there's some 500 pages of test reports and documentation that go into it. And at all stages through this, the system is tested to ensure that it discharges. So after 96 hours of vibration testing, the system is tested to ensure that it still discharges and it performs as it should do. So it's an extremely robust set of standards, and it's why not a lot of manufacturers have yet to achieve this standard, is because of the difficulty in achieving the standards that they've set of the systems. So the fire testing overview, we haven't got long left, so I'm going to flip through this. The fire testing overview, some of you will have seen these videos and some of you will have not, but the fire testing video is a controlled mock-up engine bay that simulates, or tries to simulate an engine bay with obstructions, an engine block in the middle, and then a number of test parameters around it. So we will just play this video. I'm just going to pause this and talk. So we're going to got mock-up engine bay in front of us. We've got 2 obstructions left and right. So you can see, bring my mouse on here and here. And we're going to set up a number of fires in this enclosure. This is an open enclosure test. So at 1 minute 30, the fan starts, and that simulates airflow in the engine bay. At 1 minute 50 on the counter up here, we start spraying a hectane mixture, which is a flammable liquid mixture, to simulate a burst hydraulic hose. And then we manually activate the system at 2 minutes. None of this is automatic. This is enabling a pre-burn hopefully the video sort of caught up. What you can see here is the dry chemical system has done its job, and what we're doing is we have the wet chemical spraying on the simulated hot parts of the engine bay to cool down those areas that we talked about, the reignition hot areas. So we're going to run out of time here, so I'm going to forward this. This is another test, and this test is where the water-based systems fail to work, and this is exactly the scenario we saw on the shredder earlier that burnt out, and this is a hidden fire test. So we place fires at the bottom here. This is an enclosed test, and what we do is we run to see is the dry powder totally floods the enclosure that we're protecting and extinguishes all of the hidden fires. So we're at the 45-minute mark, so we're going to flick through this. This is the mechanical vibration test. Directions that is particular that's subjected to in that direction. We turn the table and then we turn it again. So all three axes is tested for 32 hours, and if I compare that to factory mutual approval, they are only subjected to 4 hours in each direction, whereas we're testing for 32 hours in each direction. And
also on that point, there's a series of shock tests, and it basically equates to 5,060 shocks between 10 and 20 Gs. So that goes on after those 96 hours as well. So it's a pretty robust vibration and shock test.
So in terms of where do we sit with the market at the heavy vehicle approval, we're the only global fire suppression company currently certified to PMARC 199. We have the highest rating available, an A+, and we have the highest level of openness, level 3. When you're looking at the old approval for buses and coaches or light vehicles, PMARC 183, we're also the leader for system size and rating for that as well. So brands like DAFO, Fogmaker are still a C-rated system even on PMARC 183. So at the moment, we're market leaders for 199. And even though we will have competitors join us, what we've done is ensure that we have the smallest system to ensure that even the smallest parts or smallest bits of kit can be installed with a certified PMARC 199 system. As you'll often find that people will claim to have a PMARC system, but will actually fit a much smaller system which doesn't carry the approvals. So we've designed our range of systems so regardless of the size of the machine, you can fit a certified A+ PMARC 199 system. So just a summary really from us. What do we do? How do we do everything? We have world-class documentation. Ed actually oversees all of the documentation, whether it's training or system documentation. The sample of that you can see on the screen, and some of you will have seen that in content that we've had from us. World-class training, so we offer on-premises training, online training courses. Our training courses are filmed with our global engineers in each step, and those steps are used by OEMs and other global manufacturers. World-class communication, we work with all of our distributors through a number of communication platforms. We understand a lot of frustration of suppliers of other systems. For us, the priority is the customer, and the priority is the distributor. So we work round the clock to ensure that our customers and distributors and their end customers are looked after in a manner that we deem to be acceptable, and we ensure that, you know, regardless of anything that arises with systems support, we deal with it in an A+ way. So yeah, it's a big part, and a big part of our company culture is looking after our customers and making sure that every step of the journey that they take has been supported. We do a lot of all of our marketing animations that you might have seen are all designed and rendered in-house, so we're able to support a number of OEMs and distributors in custom animations like you can see at the bottom. And all of our R&D is also performed in-house here. And we also have the test rig that you saw earlier. We also have our own version of that here, which we conduct pre-testing on, as well as demonstration for OEMs and partners as well. So anyone wanting to see systems tested or want to use the test rig from our suppliers of our system, we always invite them in to be able to use it. And then the final part from us, I know it's getting a bit rushed, these are just some of the brands that we work with around the world. Different systems, we, for example, fit the multi-launch rocket system at NATO with their fire suppression systems to Rolls-Royce, Komatsu, Caterpillar, preferred suppliers in the UK for brands such as Caterpillar, Volvo. So we work with global brands on a range of different systems. But obviously today's presentation has been centred around heavy vehicles. So we're 4 minutes too late, so apologies for 4 minutes. We'll have to trim it up a little bit. I think this has been the fastest time we've ever done a presentation on heavy vehicles, so it's not a bad achievement. Just having a look at questions now. So what are the system sizes? So the smallest system size the smallest vehicle system size is 4 kilograms of both agents, so 4 kilograms of dry chemical and wet chemical, and we go up to larger sizes for much larger pieces of equipment, so up to 40, 50 kilo size systems. And the benefit of our system is it can be obviously connected to multiple cylinders. So you could have 2 4 kilos if space is a limiting factor for you, or you could choose to opt to have 1 cylinder. So the test system in the video is actually a 6 kilo dual agent. So that's 6 kilos of dry powder and 6 litres of foam. We've got some videos if you want some more with 4 kilos, with 4 kilos of powder and 4 litres of foam. So we've got all of those videos which we can share with whoever would like. So if you leave some comments in here, some contact details, we'll get those across to you. So DOT and CE. So yes, we're both systems available in DOT and CE. With DOT cylinders or CE cylinders, and then the DOT cylinders have pressure relief devices. So do we have FM approval and UL? So UL don't do a vehicle system approval at the moment. FM approval, we don't have FM approval. We went down the P mark to start with. However, after completion of the P mark, FM is something that we are now looking to move on towards now. Let's have a look.
I guess on the one there about the criticised for not testing high enough pressures for the feed for the diesel spray, I guess that would be. We do know that FM does have a higher pressure flow rate on that, but there's actually 2 feeds on the P-mark systems. They move it from the front to the back. So there's we test the whole system in different areas as well with that diesel spray.
Yeah, I'm going to click this. Oh, okay. I need some more practice on it. So AS 5062, the system is currently going through AS approval at the moment. So we'd expect to have that in probably about 3 months, 2 months. The AS standard testing is a little bit different from PMARC, although a lot of the tests and physical tests of the system and quality tests cross over. The fire testing is slightly different, as is the vibration, but one of the crucial things is PMARC exceeds all of the AS standard testing. So it's quite unknown about PMARC's vibration testing, but it is the most severe vibration testing out of any vehicle standard in the world. Okie dokie. So, is there any other questions? Hopefully it's been,
If you scroll down, that's one.
someone there? No. So hopefully, I really appreciate everyone's time in the webinar today. Got some more questions which I'll answer. If you've got any more questions on the matter, we're going to be sending out a follow-up email to this with a copy of the presentation and some contact details for our internal staff. You'll be able to contact and get some more information. I will also copy a YouTube link in there so you can see some of the videos that you've seen today.
On the last one there, where we've got which NFPA standards follow for the stored pressure cylinders, because the PMark isn't following any of the NFPA standards there, but the temperatures that are used in the temperature cycling are from -40 to +80, and that again is the range for the dry powder system. And then once it's gone through that temperature cycling, we then actually subject that system to the 96-hour vibration and shock tests. So it has a pretty hard life, but yeah, we can, when we go through to do more American-based standards, yeah, the NFPA will become more apparent.
So in terms of what do we use for detection, so on the systems that we've been talking about today, it's a pressure loss system. So that's a linear plastic pressurized tube that obviously melts and then releases the pressure in the tube and actuates the system. We do have electronic actuation options using the same valve technology. So we've got a range of detection systems that we can develop. We've also got a range of electronic supporting systems like a status indication module that sits in the heavy vehicles. We've got a question there, what would be the operating temperature? So the operating temperature of the system on, I can't remember what it is on the certificates, +90.
Well, yeah, the main thing is it will depend on the environment. So if you have high airflow and if the detection is not as close to the risk, that all changes. But the general rule of thumb for the red detection tube is 175 degrees and then 195 for the blue.
So we get, one of the issues, it's probably a relevant thing to bring up, one of the issues with the pressure loss systems, or the traditional systems that people know of in the market, the tube is never specially developed for heavy vehicles, as someone commented on a chat earlier. You know, the operating temperature, or the ambient temperatures that the system's operating in, have an adverse effect in actuation. So the tube we developed activates at the same time the conventional linear heat systems will activate that as well. So we use a different type of detection tube for heavy vehicle systems or any vehicle systems, buses and coaches, heavy vehicles. And that's also separately tested at RISE as well on another standard. So I think we've answered all the questions, and I think the presentation sort of worked without any major issues. Hopefully everyone sort of got something out of that presentation. I've noticed someone said, can you share your email? After this, you'll get an email from the marketing team, and they'll give you some great contact information, who to speak to, and then also send you again a copy of the presentation and some videos that we've seen as well. Any further questions, guys? Have we got one more? Let's see that. Thank you very much for joining us from the UK, and hope everyone's staying safe and well with what's going on in the world at the moment. And we'll see you again in a couple of weeks for our next seminar. Take care, guys, and we'll see you again soon. Thanks for coming.
Thank you. Cheers.